So now we'll look at exercise 1A, question number 7. A remote control car travels forward at 6 meters per second in drive and backwards at 3 meters per second in reverse. The car travels for 10 seconds in drive before traveling for 5 seconds in reverse. So actually, let's visualize the scenario. So let's say this is the starting point. Travel forwards at 6 meters per second in drive. Let's say that this is the direction, the forward direction. So 6 meters per second for 10 seconds. So it actually travels 60 meters. This and the speed is 6 meters per second, and it travels this way for 10 seconds. So it is traveling at the same constant speed, that is 6 meters per second for 10 seconds. So the distance traveled is going to be 60 meters. So constant speed, if the speed is constant, is equal to distance by time. That is, if the speed is constant. So distance travel will be speed into time in that case. Simply speed into time, since the speed is constant. So in this way you travel 60 meters. Now it travels backwards at 3 meters per second in reverse for 5 seconds. So for 5 seconds you travel in this way at 3 meters per second. So the distance you move in this way 15 meters. So this is your current position after traveling forward and also backwards. Now question number A is asking the displacement from its starting position. So displacement will be this distance. Okay, so it's what? 60 minus 15. So it's going to be 45 meters in the forward direction. Okay, so this will be the displacement. This distance will represent the displacement in the forward direction from the origin. Now 7b, find its average velocity in the direction in which started its driving forwards. So average velocity is equal to change of displacement or average displacement. So after the motion, what is the change in displacement? Actually it is 45 meters. So change in displacement 45 meters divided by time. What is the total time? 10 plus 5, 15 seconds. So the average velocity is going to be 3 meters per second in the forward direction. Okay, basically change in displacement by time, by total time. Then change in displacement is given by your answer to part A. Now find the average speed. The average speed is total distance divided by total time. So what is the total distance? 60 plus 15. So that is 75 divided by time. So the total time is still 15. So the average speed is going to be 5 meters per second. Okay. So here let me just clarify one more concept. I hope you understood this very easy problem. So let's say you travel the whole world. This is your origin. You travel the whole world and you come back over here. Then your total displacement is going to be change in displacement, or average net displacement is going to be 0. Your displacement is 0 since you are back to the origin. Your distance from the origin is 0. However, you have traveled a lot of distance. So in that case, since the displacement is 0, or change in displacement is 0, so your average velocity in that case will also be 0, though you will be actually having a speed, average speed. Now let's look at question number 11. Two cars are racing over the same distance. They start at the same time, but one finishes 8 seconds before the other. Okay, So two cars are racing over the same distance. So one car travels faster and one car travels slower. So the faster one average 45 meters per second and the slower one average 44 meters per second. Find the length of the race. So the length of the race actually is same for both the cars. So faster one is traveling at 45 meters per second and the slower one at 44 meters per second. Faster one 45, slower one 44. So they travel the same distance. Now, and all of them, they actually have the constant speed. So the distance travel is just going to be speed into time. Now, so find the length of the race. So the faster one, but one finishes 8 seconds before the other. So you could actually say that the faster one, it will finish the race faster, definitely. Okay, so distance, so let's say the faster one takes t seconds to finish the race. So the distance of the race will be length of the race 45 t. Now this one, the one traveling slower, it's going to take 8 seconds more. So speed into the time is going to be t plus 8. Okay, so if you solve this, if you find the value of t, the value of t comes as 352 seconds. That's the time taken by the faster car. Now, what will be the length of the race? So 45t, 45 into 352. So the answer that you get is 15840 meters.